back, everybody. Good evening. So as you can see, while we're waiting to get started, I wanted people to maybe take some time to download the app for what we're going to be focused on this evening. I do want to say this is a brief 30-minute session, and you may find it challenging to follow along on the app if you're not already familiar with it. So we encourage you to spend some time checking out the app after the session if it gets a little bit too fast during the session. So welcome. My name is Lori Coates. I work with EIE at the Museum of Science in Boston. And we create STEM curricula for pre-K through 8th grade learners. As part of the professional development team, I facilitate learning opportunities for educators who want to implement high quality engineering and computer science with their students. Normally, I would be traveling all over the country doing that. But unfortunately, we are not able to do that like you. So now I do it a lot by webinar. We're so excited to have our friends from MindLabs join us today to share some really fun ways to think about augmented reality. I'll be monitoring the chat during our time together, so please feel free to interact with us in that way. Please note we're not going to be using the Q&A feature and hand raising. Don't worry about that. Just chat in any feedback you have, questions, or if you're responding to something, that's where we'll be looking. So with that, I'm going to ask Amanda from MindLabs to introduce herself.
Hi, I'm Amanda Thompson. I'm the CEO of MindLabs and have been behind a lot of the curriculum development pieces of this. And I also star in our movies as Dr. Pixel. So she's kind of our double agent that thwarts the bad guy while helping the trainees learn something about circuits that they're working. So very much welcome to everyone. And just saying again what Lori mentioned, there'll be places where I'll point you to opportunities to interact with the app if you have downloaded it. So for example, on this particular screen here, if you have the app available on a secondary device, like you have your phone or a tablet nearby, you can download the app. And then there's a choice to go into what we call the create space, which is the open-ended space. And you can open a room, and I encourage you to open an individual room, and inside of there is where all of the fun will happen. So you'll get a chance to look at cards and see what's going on there. But again, if you don't get that done ahead of time, I will have, you'll still get to have a good time as well. So Lori, you want to get us started with a brief overview of the engineering design process?
Sure. I imagine some of you are familiar with the engineering design process and what EIE does, but EIE, as I mentioned, we do curriculum for pre-kindergarten through 8th grade. We are focused on engineering and computer science, and the engineering design process that you see here really kind of sums up what we do. This process, beginning with asking questions, identifying what is the problem that we're looking at, what have other people learned that could help us solve this problem, then getting into brainstorming and imagining how we could solve the problem, then focusing down into, okay, how can we design a detailed plan? Taking that plan and actually creating some sort of solution, then testing and deciding how do we improve. So that process, the cool thing is it could be applied to engineering, but it can be applied to pretty much everyday life. We have people using that in ELA. We have them using it at home when they're having a challenge in their family. So this engineering design process is really the center of what we do. And it's a great way to help kids understand themselves as problem solvers in general.
Wonderful. And this whole session is actually really centered around the engineering design process and ways to insert the newer technologies around augmented reality and also engineering notebooking with digital technology. So a nice flavor as well that's possible with these types of technologies is to have kids working remotely and still be able to capture their work as well while they're remote in a streamlined way. So again, we build around the engineering design process, and through the 3 sessions that we've worked on have been sort of showing how the new technologies can fit in. So our first session was around building confidence with beginners. The second session was around troubleshooting, the ability to practice some of these scientific concepts and engineering concepts before, as a building block to the design process. And today's all about the design, as well as the ability to collaborate even if you're remote. So that's what we're going to look at today. I'm really excited. So again, we're showing how there's an intersection between design projects that you may be familiar with in the classroom and ways to use emerging technologies to bring out additional elements of that may not have been possible or as possible in the classroom. So we're going to be working today on engineering design through motivation, the motivation of the process, criterion constraints, digital design, and notebooking. And then, as I mentioned, collaboration. And we sort of focus our work on design projects that work on solving problems created by our little villain here in our picture. So first step is talking about how to motivate engineering design for your students. So in our app, or when we work with it in the materials that we put together, we have this dynamic of the villain and the Dr. Pixel and the little robots that are helping design solutions to problems that arise because of Dr. Stonebreaker. So just as an example, one of the problems that we work through in the curriculum is how do we use our circuits to help stop the villain? And one of the things that they need via the storyline is to help keep watch for the villain. So how do we build somewhat of an alarm system? And this is a common engineering design problem that comes up with circuits, or the way that we address circuits in the classroom. And probably you're familiar with, but one of the emerging hottest things about STEM education is trying, and just all education, is trying to have an element of place-based education. So when you're motivating design projects, it's great to have a scenario that's familiar to the students and can translate to what they are familiar with. So for our robots, dealing with Dr. Stonebreaker is place-based. It's right in their lives. It's something that affects them. And so a good way to start thinking about how might you use this with your students or children is, what is a place-based problem for them? And what does that mean? It means using things that are in their culture, their landscape, their experience as a foundation for the problems. The EIE curriculum has two really nice examples of this as well. They have Light Up the Night, which is oriented around kind of city life. And it has an art festival that you're designing for to mimic the Northern Lights, which is something that's in the culture of the place that they're visiting. And there's also an alarm circuit around helping alert more of a rural-based problem with remembering to feed some animals that are on the farm. So just some examples of that. I put some resources in the folder that we'll link to at the end about that as well. So if you want to look into that more. But that's the starting place, is motivating the problem. So again, in our question or our curriculum, we're trying to design a circuit to warn little robots if anyone sees the villain in place. And we start the engineering design process that way as well. So as talking about a goal. So the next couple of slides that we'll see, or several of the slides, are around an engineering design notebook type of interactive slides. And these slides can be either drawn out in a physical notebook, or if you're remote learning, they're great for a Google slide. They're great for Nearpod, if you're familiar with Nearpod, or if you just want to edit the PDF as they are. So we provide this as a resource after this session, is this really nice engineering design notebook that's generalized, actually doesn't have a problem in it at all, that you can use to apply to whatever problem you consider in your place-based design, or one that you've used before as you work through the engineering design process. So when we talked about the engineering design process, the first thing is to establish through questions what the goal is. And so Anne here, that's our little robot's name, is telling us that she really wants to be warned if the villain's spotted in the village. So these are some of the first questions that kids would be encouraged to ask as they work through it. And here would be an example or a little of what their writing might look like. So engineering design process is a great place to extend kids' writing skills. And we know the implementation that we're working with in our home state of Indiana the kids have, the teachers that are focused on writing have really emphasized these elements and had some really great work come from the kids on through the design process. So writing out the goal as a first step, and then understanding what the criteria and the constraints are. So I've left this blank, so this is kind of what you fill out as you went. There's math tie-ins as well with the engineering design process, particularly if you design before you build, which is what the digital design allows you to do. So you can create a budget, you can make a design that's digital, and then translate that to a constraint that might be involved with how much certain pieces cost. And you might have a limit on the cost. So what pieces are available, how much would it cost to buy them, would be tie-ins to some math curriculum as well.
And Amanda, if you don't mind me popping in, that's a place where we can really, using different criteria and constraints can really either make that challenge more challenging, or you can make sure that different levels of kids can be involved based on your criteria and constraints.
Yeah, absolutely. So, you could have a very set limited amount of materials, like you can only use this, or you can say you can use anything that's here, but you have a budget. And yeah, it does adds like an additional level of challenge to it. And you might be able to implement it in an improvement stage, like, oh, we only have the budget for something, limited. So how could you change your design? So when we set up the scenario to have different criteria for success, like what else do I need to know about this alarm system? Where is it? How many people? How does it need to work? So we tell them it has 3 different places, and we have them map out the 3 different places where the villagers might end up being as they're trying to warn Anne. And this is the first place where you see sort of a screenshot of what the app kind of looks like. And so this is a physical drawing of a map. And then on the top of it, you see the augmented reality little Anne character that shows up if you're viewing her card through the app. So it's pretty neat, and kids really get excited about working with it. So this is what their desk would look like, right? They could have a printout of a sheet that had this on it, and when they look at these cards through the app, the robot appears here, and you can start to add the other pieces in. And if this seems like, whoa, I have no idea what's going on, I have a really short video that we'll watch at the end. That'll help sort of tie these pieces together about how a design might happen in a digital space. So again, just a couple more criteria for success, and the questioning, what else is important? What do I need to know? And I need, the switch, the system that you designed to be able to be set off from many different locations. That kind of helps us set up the tests that we'll do down the road to be sure that your design has met the requirements that have been laid out for it. So we know from our map that each of these 3 spots kind of needs to have a switch, right, to turn on the alarm. And we'll have to wire it correctly so that the alarm turns on if just one of the places flips it. The first instinct is to wire all the switches in a way that all 3 of them have to be flipped to work, but you want your alarm to work differently than that. So that's kind of where the challenge comes in, and the understanding of how circuits and energy flow works. Constraints, like we talked about, maybe how many pieces you have. So that's what I'm showing here. You only have 1 energy source. You have 3 switches you can use. You have a light bulb and a buzzer. And this is also an interesting, element. You can have an and or here to give some creativity. Do you want to have a sound-based buzzer, a light-based alarm, or both? How do they put it together? So it gives some flexibility and creativity in the design. And again, that all comes to play. You can see how we'd start to fill out these journal items with those different things. So this summarizes how it might look. We're going to warn Anne quickly, and we have the idea that we can use light or sound energy to do it. We need 3 different locations that can each warn her, and we need to make sure we only use the pieces that we have available to us when we do it. So this starts to hint at what the test might look like. How many do we have, and how many did I use, and make sure I passed that criteria down the road. So I wanted to pause here really quickly and just also highlight that inside the application, there's also these small lessons and interactive exercises to help the kids get some practice at how things work inside the circuit. So for example, the switch is really something that comes into play when you want to have very specific objectives for your circuit. And so we walk through that with talking about what switches do and thinking about what's going on inside of that switch, which many of us probably haven't seen what the inside of a switch looks like. And so that's where inside the lesson on switches is right here demonstrated. And when you open it up, again, here's where you would, in that create space that I talked about at the beginning, if you weren't here, then inside the app, if you select into the area called create and aimed your device at this card, you'd see it animate. And I have it animated as well right here. So this is what it would look like if you pointed your app at that card that was on the slide before. And so an element of, again, these neat digital resources is that what the kids would have available to them is just a set of cards, of simple cards. But when they put them in front of the app, like here's the one that we're looking at right now, then the card appears to animate immediately. And offline, when they're not looking at the device, this card very well is animating in their little brains as they look at it as well, and connecting those ideas that we're trying to get them familiar with. And we have, through testing, shown that the vocabulary and the conceptual understanding of kids through circuits working through the concepts in this way has been very effective. And then the next step is to imagine. So once they know the pieces, they might have very different ideas about what they do with the pieces they have, and what kind of solution they put together, and what our little robot is looking for here. So what are the solutions that are possible? What are the solutions? And this could be a group activity as well, right? You're brainstorming the different ways you might use these pieces to solve the problem, and then go ahead and plan. So the planning, and this is very familiar for young students, might be something they've drawn on a piece of paper. So you'll recognize this as the piece of paper that I showed earlier, that they could be drawing, here's the village that I saw, and I'm going to put a switch here, and I'm going to put a light bulb here, and I'm going to put a buzzer here, and maybe even drawing where they think the little wires should go, right, as a first attempt. And this is where a lot of engineering projects would jump to actually building this design. But with resources like simulation, and in our case, an augmented reality simulation, the kids can go build a digital version of it and do their troubleshooting and redesigns and iterative processes to get the thing working the way they want it to before they go to the physical. And working with some of the circuit physical materials can be pretty challenging for kids in terms of just getting them connected right, and making sure that that orientation is correct and everything's wired the way you want. So it's great to be able to do some of that digital redesign and iteration that could get left out otherwise in the digital environment, and also be able to see if it's working or not. So let me see, I haven't been paying attention to the chat very well. So Lori, please stop me if I'm missing that.
We're all good.
Okay, so that's where we can go in, like I said, into the app. Once you have your plan, you can go into the app and build it out and do what real engineers do, right? That authentic engineering process of building the digital or simulated version of the design. So we're going to take a look at what that might look like here in the create space. So here's what I said. You go into the app and select create. Create is the open-ended area where challenges, or we saw the switch exercises earlier. And we can push from create. We can play individually, so we can start our own room. Or what's really, really neat about what we've put together is that you can actually join multiplayer rooms where your students can be looking at the same digital design from their own device. Even if they're at their own homes, they can look and interact with the same design together. So if you're using Zoom or Google Classroom and you push the kids into breakout rooms or small groups, or they're getting together outside of the class, or kids are working on something even with grandma, you can go into a space where you can be working together on the same digital design. And I know this is sometimes really hard to mentally picture. So that's where I'm going to take us really quickly to a video that's going to show, even though these two kids are in the same space, they are looking at their own set of cards on the tabletop. So it's like they are in different spaces. They have their own sets of cards. And you can see on the screens that they're interacting digitally with their designs. So I'm going to just stop talking and let you see it.
Dear Pixie, I don't understand how to collaborate with MindLabs. Can you show me? Thanks, Miss I from Indiana. Pat, can you help me?
Sure.
Let's show everyone, Pax.
Yeah?
Let's show everyone how to collaborate. First, what do you push?
You push create.
And then what?
New room. And then whoever wants to join will type in the code.
So what does she need to push?
So you need to put in V.
Which button does she need to push? Join room.
V C H E
D.
D. Okay. Join.
Now what if you were in a different state? Could you still do that?
Of course, as long as you knew the pin.
Really?
Okay.
That's cool.
All right.
In Japan, I have
Now
to
which
cross
character
the
card do you need in create mode?
Well,
It says place the and card in the camera. So like this.
Did you find Anne yet? Oh, there she is. Add a battery, please.
oh, I thought Pixie was doing it.
Okay, there's the
You
battery.
can see that
Pixie,
she
can you add
added the
a
battery.
light bulb?
You can see it.
Yeah.
And now she's going to add a light bulb, which would also come into view on his screen, but she added it in.
Push it.
And you'll see in a minute her,
Oh, and now
Yeah,
you're drawing a
adding
wire.
a
Pax,
wire.
do you see her drawing the wire? Oh, you're drawing a wire.
he's drawing the second wire.
Wow.
Okay, now kids, can you work together to put a switch in there for the light?
Me.
Well, why don't you both put a switch in and see how to make it work for each of you?
Okay, let's.
Oh, yeah, my switch in.
Now, how are you going to wire it in there, Pax?
So he's doing what I said is their first tendency, which is wiring them
Let's see if that works.
so that you'd have to flip both.
Well, that way it has to have
that
both
to work.
switches on. Can you figure out how to wire it where you only need one switch?
Yeah.
Or I mean, only one switch needs to flip? How would you wire it so that only one switch needed to flip?
So just kind of letting it run
gotta
to
put a
see, you can
switch
see
in.
how she's adding things, and then he'll draw a wire,
Take it
he'll
away.
draw a
Now, how
wire,
would you wire that
and then
switch
really
so
work
that it...
together to get
This.
this outcome.
Here. Then this here.
Oh, looks like Pax is putting one in for you too.
That.
Oops. There we go.
It worked.
Good.
So it's one app, but they can be in two different places to work on it together. And so that's really something that, you know, in the next couple of weeks or months, as we're still sort of apart from each other, is a way for the kids to still be able to work on hands-on feeling engineering projects. So that's something we're pretty proud of working on, and really feel that it's a great addition to, or a way to accomplish some of the hands-on activities that may have been used in previous years that aren't possible. Okay, so as a recap of how it works, you can open that create space, point the camera at Anne as you saw her do, and she appears above it. And then you add in these cards. So right now, if you had the app and you were able to, and you're pointing it at these cards, you would see those 3D images of the light bulb and the battery and the switch appear above them. And as you saw them on the screen, draw the wires to connect them. And you can do it looking at the screen alone. So as Lori's mentioning, after the session, I make available slides like this where you can go and experiment with how it works and how it looks. Now, it's not as good of an experience as the physical cards that we have available because the screen, flashes, and so you'll see some of the images appear to jitter a bit if you're using the screen version. But it's still a good way to get the feel of how this type of experience could work in the classroom. So again, one of the things we emphasize, it's great that can be done and easily undone and revised when you're doing a digital design, is this testing phase. So you throw in that extra step, and Lori said this when she was going through it as well. She said, test and improve. So it's test, try to improve, use your creating skills, test, improve, create, and to go through that loop until you've achieved that goal to your whatever you're looking to do. So for example, if we went back to this circuit that they planned out, if they built the circuit as it was shown here, first of all, you might not have noticed it, but they didn't draw any battery in there. So the circuit is missing a battery as a starting place. So that's one problem with it. Secondly, as Pax drew, or as I suggested, because these switches are connected in order or in series with each other, you'd have to flip each switch to get the energy to flow through the circuit instead of just one of the switches. And then you'll notice up here in the top left that also one of these switches is wired all on one side. So that switch effectively does nothing. It's just sitting there. So these are some of the troubleshooting things that you actually can learn as concepts inside of the app. And then you'll be understanding to look for them as you're in this test and improve step within the engineering design process. And, you know, as we've talked to teachers when we were building this up, one of the things that they said that happened, that they regrettably happened, is that they just didn't have the time to repeat or iterate designs, or they felt like, you know, they didn't have enough materials. Or the time for them to undo the physical version that's very consuming to build in that first iteration. With circuit materials, another thing that can happen is that if the kids are wiring them improperly, number one, they can be dangerous, and number two, they can you know, blow out some of the pieces as well. So the light bulb can burn out, and the pieces then don't work. So there's always an issue of having some of the defective pieces around. And our app can demonstrate, or you can use these digital simulations to demonstrate those principles and even let kids enjoy them a little bit. So one of the favorite things that we've seen is that kids like to go in and purposely set up short circuits so the battery gets all hot, and they see how many of them they can do, which, you know, builds excitement, which we know kids enjoy about the engineering process, but it's something that would be dangerous to do outside of the app. So it lets them explore those kind of boundary conditions a little bit more as well. So again, going back to what the design notebook could look like, you could say, did my design warn and quickly? So a light and sound is fairly quick ways, and electric energy to deliver a message. So that's one that probably they would pass. But this is the one that would be challenging. If I just flip one of those switches, did it set the alarm off? And for each one, so check each of your locations, did it work? And likely they have to kick back into the design process to improve their designs and get it working the way they want to. And then lastly, did you only utilize the pieces that were provided to you? So those would be the tests. So here would be an example of what a student's work would look like to get one switch to work. And what often happens to figure this out, they get one switch to work, and then you encourage them, okay, to replicate what they did with the one switch to get it to work, to get a second switch to work and a third switch to work throughout the process. And we have a button that allows them to quickly take a screenshot of their work. And then on the iPads, particularly, I'm super familiar with iPads, there's an easy way to annotate those screenshots to capture their thinking about their designs and why they're working. So this could be your final result of the digital design, or you could take the digital design to the physical materials like those offered by the Museum of Science. So that's where they go into their final design, and at that point they might take a screenshot and have to take the time to explain or describe what they were doing with their final design. And lastly, there's lots of room for reflection and sharing what you've learned through connections, discoveries, wonder, challenges, sharing, and feeling. So all of those also can be captured in the engineering design notebook, and we have provided that as well. So I know we're right at time, so moving quickly as promised, but hopefully you saw some things that excited you. There is an opportunity to go get those instructions and a free demo set for the cards if you want to try them by going to our website right here and signing up for that, for those free demo card sets. So it's right here at exploremindlabs.com. All of this is, and I can type that in the chat pod as well. So it's at exploremindlabs.com. You can get to lots of free stuff, as well as the webinar recordings and things will be there as well. We're going to throw a survey link in here as we wrap up. The survey link, I'll just throw it in here. I know Lori has it too, but the survey link, if you go and fill out this survey tonight before you go to bed about the session and about sort of the things that, again, interested you about potential for augmented reality, by midnight tonight, you will be entered in and have the opportunity to win this free game set. So this is not the classroom set, it'd be more like an individual home set, but you have the opportunity to win that. And we do also have larger volume 30-unit sets as well if you're a teacher. And as we close, just a reminder that the Science and Engineering Elementary has amazing materials available for you as well, individual or classroom material kits, face-to-face units. We have on our YouTube channel lots of we have some episodes around the circuit ideas that correlate with the lessons. And we have a 5 full days worth, not 5 days, but 5 class sessions worth of lesson plans that you can also utilize if that's the way you apply this. But just as much fun to have it individually with your kids at home. So a few minutes late, apologize about that, but I'm excited to have the opportunity to share this and hope you will find it that we can make STEM possible for your kids, even if they're, remote learners.
Thanks so much, Dr. Pixel. It was really fun. And this is a great way to learn. We're glad that you spent the evening with us. Thanks, everybody. Have a good rest of your evening. Bye.
Good night.